If you want to learn the parts of the limbic system, you should know how to draw them. I'll teach you an easy method to draw the diagram of limbic system, so you will never forget the parts of the limbic system. So please take a paper and pen and please draw this diagram along with me. You'll never forget the parts. Yes, we'll draw that. The diagram of limbic system. You can imagine this as two seahorses lying supine like this and reading under a bulb. Just imagine two seahorses are lying supine like this. They have a book like this and they are reading. On top of the head there's a bulb which gives them the light. Two seahorses reading under a bulb. That is the diagram of limbic system. So let's draw that. So let me draw two seahorses, an outer seahorse and its tail, an inner seahorse and its tail. Can you imagine this? Even if you don't agree that it doesn't look like a seahorse, I'm telling you it is a seahorse. You have to believe that it is a seahorse. Two seahorses, they are lying supine like this and they are reading like this. On top of the head, we'll put a bulb. We'll draw a bulb on top of the head. From this bulb, you have light rays coming up. And let's throw the light on the heads of the seahorse. All this is happening under the sea. It's a seahorse, so it happens under the sea. So let's draw sea, but we're not going to draw sea like this. I'm going to draw two seas, not like this, two inverted seas like this. Seas, but inverted sea like this. I'm going to draw two inverted seas. This is one sea and the other sea. Two inverted seas like this. This is the diagram of limbic system. Two seahorses are reading under a bulb. Two seahorses are reading under a bulb. All this is happening under the sea. So I have drawn two inverted seas like this. Now let's mark the parts of the limbic system. What are the parts of the limbic system? The outer seahorse is called hippocampus and its tail is called mammillary body. Mammillary body. The inner seahorse is called stria terminalis and its tail is called hypothalamus. Just above the hypothalamus, we'll put the thalamus. Just above the hypothalamus, thalamus. What is this bulb which is there? Which is that structure in the brain which ends as bulb? Yes, the olfactory bulb. This is the olfactory bulb. From the olfactory bulb, you have light rays coming out. So I'll name them as the light tracts. Olfactory tracts. Medial olfactory tract, lateral olfactory tract. Medial olfactory tract, lateral olfactory tract. And this band is called diagonal band of Broca. A band of light coming from there. Diagonal band of Broca. What are the two seas here? We'll name them. The inner sea is called corpus callosum. The outer sea is called cingulate gyrus. Cingulate gyrus. Nearby the hippocampus, we'll draw the parahippocampus. Para means nearby. So parahippocampus is a part which is nearby the hippocampus. So near hippocampus, parahippocampus. The heads of the seahorse. You can name the heads of the seahorse as amygdala. So both the heads of the seahorse, this part we can name it as amygdala. The heads of the seahorse is called amygdala. See, all this is present inside the limbic system. Limbic system itself is present on the temporal lobe. There are four lobes: frontal lobe, parietal lobe, temporal lobe and behind occipital lobe. See, of this, limbic system is present in the temporal lobes. The innermost part of the temporal lobe is called as uncus. So in the innermost part, let me draw uncus. So all these are parts of the limbic system. This completes the diagram of limbic system. So quickly through the diagram of limbic system, two seahorses reading under a bulb. An outer seahorse, hippocampus, its tail is called mammillary body. Inner seahorse, stria terminalis, its tail is called hypothalamus. The heads of the seahorse, you name it as amygdala. Just above the hypothalamus, thalamus. Olfactory bulb, the bulb on top of the head. From olfactory bulb, olfactory tracts, and there's a diagonal band of Broca. Nearby the hippocampus, parahippocampus. Para means nearby. The two C's, the inverted C's, C for corpus callosum, C for cingulate gyrus. All this is happening inside the temporal lobe. Innermost part of the temporal lobe is called uncus. So all these are parts of the limbic system. There is a connection within the limbic system that is called Pepys circuit, internal connection within the limbic system. You call it as Pepys circuit. What is this internal connection within the limbic system? So let me trace the Pepys circuit. The Pepys circuit from hippocampus to mammillary body, from mammillary body to thalamus, from thalamus to cingulate gyrus, cingulate gyrus back to hippocampus. So this internal connection within the limbic system is called as Pepys circuit. What is the use of this Pepys circuit? This only is the most important internal connection of the limbic system. How hippocampus, mammillary body, thalamus, cingulate gyrus all are connected within the limbic system. That is by the Pepys circuit. Very important internal connection inside the limbic system. The medial most part of this limbic system is called medial temporal lobe. I'll draw that. I'll trace that maybe in green. Okay, so let's trace that in green. The medial most part of the limbic system, which includes uncus, the parahippocampus, hippocampus, and amygdala. So this part which I have shaded in green now, this is called the medial most part of the limbic system or the medial temporal lobe. This becomes medial temporal lobe. What is the clinical importance of medial temporal lobe? Any damage to the medial temporal lobe can result in medial temporal lobe epilepsy. Medial temporal lobe epilepsy. What are the clinical features of medial temporal lobe epilepsy patients? There are two important features related to medial temporal lobe epilepsy: deja vu and jamayu. Deja vu and jamayu. What are they? Deja vu means, one example, let's say you are attending my class for the first time. You are listening to this class for the first time, my lectures for the first time. But as you are listening, if you have a feeling that already I have attended these classes, already I have seen this ma'am somewhere, already I have listened to all this, that is called deja vu. An unfamiliar situation seems to be familiar. You feel like as though you have experienced it before. That is deja vu. Jamayu is exactly the opposite. One example for jamayu, you'll be sitting right in the center of your home, your own home. But suddenly you'll have a feeling that you're sitting in a strange place. You'll have a fear. Something strange is happening. I'm sitting in an unknown place. That is called jamayu. A familiar situation seems to be unfamiliar. That is called jamayu. Why do you have deja vu and jamayu in medial temporal lobe epilepsy? Look at the parts that are involved in medial temporal lobe epilepsy. You have hippocampus, you have amygdala. What is the role of hippocampus? Yes, already we finished this. Converting short-term memories into long-term memory. So hippocampus has a role in memory. Amygdala. Amygdala is called the window of limbic system. The main important center for genesis of emotions, that is amygdala. Now, in medial temporal epilepsy, when hippocampus is damaged and amygdala is also damaged, there is a complete mixing up of memory and emotions. When memories and emotion mix up, they come out as deja vu and jamayu.